Okay. So
I have to
a
take
quick
note
one.
of those.
Welcome, Master.
Okay.
Take note of those who want to.
All right, no problem. So plus or minus, I did adding a new column, okay, which is an ID. That one is settled. So when it comes to data manipulation, we should understand that group by is also a key function when it comes to data manipulations. So if you are this data analytics person, you should understand that the filter, the sorting, that's not something new. Just understand how to navigate with Python and write the right syntax. So one of the things I want to discuss about is group by. So let me say group by now. Let me write an hashtag. Um, let's group by. Okay. Let's group the name. Group the names by the mean age. Mean age. Okay. The mean age. Let's do that. Okay. So what will I do? I will tell you group. Let me just use group underscore by equal. I can tell you DF is the data set we are working with. Okay, I'm admitting. DF, data set we're working with, dot group by. Okay. Then in bracket, the column name should come to play. Name should come to play, followed by a square bracket of age. Okay. Then I'm going to put dot main. That's the main function. Main bracket at the front. Then I should have dot reset underscore index. Okay. Then I have this at the front. So if I run this, let me just come back here and say group by. I have to copy this group by. Control copy. Control V. Then run it. Let's see what will happen. I put it have error because I was just trying to okay. Error occur. So why? Name. Wow. It's telling me the key error name. My name is not correct. N-A-M-E. So I have N-A-M-E. Okay. So let me run this now. Good. I've seen it now. So that's what I did. That's my results. So that's for data manipulation, by the way. Okay. So mind you, if I want to rename the variable name, I can do a rename. Use a rename syntax. There's a whole lot to do, but no problem. Okay. And there's something called iloc, index location, and also location for you to kind of navigate within the entry, the input, like Alex now. Alex is what's it called? A11. So that is the word A11. I'm going to mathematics. Pardon me for that. Alex is A11. Um Alex is A11. I can say Alex is A00. Then 70.0 is A01. That's it, rows to column. Such kind of stuff I can navigate. So now, there's a whole lot. But let me now say something. When it comes to data science in general, we should understand that there are steps to follow. Now, the steps to follow are very key. Now, let me now tell you. One, you define your problem. Two, the data should be collected. Ideally, data collection is not meant for me and you. It's meant for a data engineer. So when you see a statistician collecting the data, that person is trying, because there's some data whereby statistician will not be able to collect. So a data engineer will have to collect it because maybe electronically or using some kind of tools. There's some big data tools which is needed to be, you can use to collect data, like what's it called? There's one called Kebula, there's one called BigQuery, and the likes, used to analyze and compute your data set. Then after the data set is collected, they will now give to a data scientist to bring out insights and for deployment. Okay. Now at this junction, problems definition, you should know the problem that you're encountering. You have to collect the data. Then the third one is data preprocessing. One of the hardest part in the field of data analytics and data science or whatever data we're dealing with is when it comes to data wrangling. When you're preprocessing your data, okay, because data preprocessing means that at that junction, you are cleaning your data set by detecting for an outlier, by checking for missing value, for what again? Yeah, missing value. What again? Making sure your data set fits within the range of what's it called? There's thing called standardizing and normalizing with scaling. Okay. Now there's something called feature engineering. If like now I have a data set called name, age, and city. When I created class is called feature engineering because I manipulated it to create a new column. It's called feature engineering. The idea I computed is called feature engineering. When you be able to create a new column from an existing feature, it's called feature engineering. Okay, no problem. So aside that, we have, once you've done feature engineering, you talk about model selection. You understand? So for model selection, you train your model, you evaluate your model. So now at this junction, I've actually been in a statistics class whereby I have a data set, I compute my model straight up. I didn't split my data set into two. Pardon me, I don't know. I was being taught that way, and I always laugh whenever I see that happening. Maybe that's how the curriculum goes. But ideally, for my own new school of thoughts, if I have a data set, my data set should be splitted into two because the model is expected. And if you build your model, you should test your model. So we have what they call training and testing. So a large percentage of your data set should be used to build the model. Why a few percentage, a minor percentage of the data set should be used to test the model. That's why we have the word training and testing. I cannot train my data set 50% and test my data set 50%. I'm super wrong. So, but from the whole school of thought that data science comes to play, you can train your data set 70% and test it 30%, or you train your data set 80% and test it 20%. Worst come to worst, you train your data set 60% and test it 40%. You're good to go. It's allowed. I don't know. Different people with different school of thought. So I was trying to say something about what's the thing? I was saying problem definition, data collection, data preprocessing, feature engineering, model selection, then model training. Then after your model training, you have to do what they call model evaluation. At that junction, when you're talking about evaluation, you're trying to talk about predictions. Are we good? So model training means that you are training your model to see the model. The model evaluation at that junction, you're going to see what they call performance metrics to see how good the model is. At that junction, if you are predicting, there are some metrics you need, like the R square, which we call goodness of fit, like the root mean square error, the absolute mean error. Without statistics, machine learning cannot exist. Trust me. I don't know. Sorry, I used that word, but I'm very sure about that. Without statistics, the almighty machine learning can actually be standing standard on its own feet. Okay. So, and if we're working with regression, when we say regression, when you have numerical value as your target, then we are talking about root R square, which is goodness of fit, root mean square error, mean absolute error. But if your target is about label, classifying, maybe yes or no, maybe the output said this person has a cancer, this person does not have a cancer, this kind of classification, at that junction, you are not talking about root mean square error or R square again. You're talking about accuracy, precision. You're talking about F1 score and the likes, those performance metrics. Okay, and in that junction, there's this summarizing thing called confusion matrix, where you have your true positive, true negative, and the likes. It depends on your data set you are working with. Okay, so mind you, plus or minus, if after model evaluation, if you want to go into deployment, there's a stage whereby you have to discuss something called hyperparameter tuning. After hyperparameter tuning, you can now finally decide about which model is the best. Once you know the model that is the best, then you now go into model deployment, which we're actually going to do today. Okay. Okay, now good. So I know something because we talk about machine learning. There are a lot of machine learning algorithms. We have linear regression, we have logistic regression, we have decision tree, we have random forest, we have support vector machine, the SVM. Okay. We have KNN, the care nearest neighbor. We have neural network. We have gradient boosting. We have family of clustering where you have the k-means and the hierarchy clustering. And we have the PCA, the principal component analysis for dimensional reduction. Okay. And I know something, there's some crazy algorithm that's like, it's called cat boosting, ADA boosting, and the like. There are a lot of algorithms. So which means one has to understand why I want to use the algorithm to implement. Okay. In today's section, I'm going to a new section now. I'm going to discuss about a data set which I created, and from data set I did a data frame. Then I have some inputs and outputs. I have features, I have targets. I will explain why these are called features. I explain why these are called targets. Then I now only use one algorithm, which is linear regression. I should have tested for logistic regression, decision tree, random forest, naive Bayes, and the like. But I only used one algorithm. Mind you, if I want to test 5 algorithms, the algorithm with the best performance is what I will pick. I will now save it. Then I'll now go and build my front end. I'll now link the algorithm to it because that algorithm is best. If I'm regressing, I'll use R square or root mean square error to decide. If I'm using an R square to decide, that is to say, an R square with a good performance metrics, like 70% upward. My own school of thought said, once I have 70% upward for my R square, that model is good. But if it's below 70%, that model is not good. Why most people said they want 50%? Wow, no problem. But ideally, if you go into real life production, you're building a model for an industry whereby they want to predict it for their sales and the likes. I will not advise you to go into 60% or 50%. I would advise you to be looking at 70% upward. Mind you, if you're looking at such kind of percentage, 70% upward, there are some things you need to be very careful of. We call them underfitting and overfitting. Underfitting has a constraint. Overfitting has a constraint. Maybe that will be another day for machine learning discussion. Okay, so at this point, I'm going to let me go to what they call, sorry, my PowerPoints. Okay, good. Okay, now I noticed. Remember this? We showcased like yesterday. Okay, our work is about machine learning application using Positron, a case study of back end and front end. Wow. So what is a back end? What's a front end? We're going to see that in a few minutes. Okay. So sorry for that. Okay. All these parts, I explained them, samples of Jupyter Notebook and the likes. Okay. I discussed all this yesterday. Now, this is my data set. This is a sample of my data set. I discussed about it. I said it has 5 features and 1 target. Mind you, in the field of data science, we call independent variable features. We call the dependent variable targets. Okay. So I described the data set. I said we have advertising budgets, we have price, we have numbers of stores, we have promotions, and we have customer rating. Those are the 5 features, which is your independent variable. Then we have sales, which is your target dependent variable. Okay, I wrote a code for the back end, front end, then a GUI, then this, and I say thank you. So let me go to Positron now. Good. And I'll come back here. Good. I'm going to enlarge this so we see what we're doing. Okay. I'm going to take this downward. Okay, good. Now, mind you, whenever you're writing code or whatever you're doing, you should have a documentation somewhere. That's why if you're very familiar with GitHub, there's always a README section. Whatever code I do, whatever step I take, whatever thing I do, I should have a README. README part is like you doing a documentation, doing a brief summary. Okay, I use pandas, I use NumPy, I use sklearn, I use this and I use that. That's why I'll be able to achieve this. And also I build a GUI using a TK inter. I also color it color blue. I did a whole lot of shenanigans. Those things discussed should be called documentation. So README should collect it. Now, machine learning application is study of backend and front end. Now, I did a description. Sales predictions application. This application demonstrates a machine learning model that predicts sales based on several features. The backend processes the data and generate predictions using a pre-trained model, while the front end provide a user-friendly interface for predicting data and visualizing the results. Good. What are my key features? 1, user input value for 5 features. What are the 5 features? Advertising budget, price, numbers of stores, promotions, and customer rating. 2, model prediction sales based on the input features. If I didn't have an input, I won't have an output. Okay. The third one, the application visualize the input features value using a rainbow color bar chart. You're going to see that. Okay. This is just like a sample. Sorry. This chart here, a rainbow color. Okay. Now, aside that, the interface include option to reset the input field and clear visualization. Now look at this now. I have a reset button. Once I click on the reset, all this input value I entered will clear off and the bar chart will clear off also. Good. Okay. Now, color scheme. A deep blue background for a modern and appealing look. Rainbow color for the bar chart to differentiate between the features clearly. Library use. tkinter for GUI components, joblimp for loading the pre-trained model, NumPy for data manipulation, matplotlib for data visualization. This project illustrates the practical application of machine learning in a front-end back-end architecture, showcasing how ML, machine learning model, can integrate into real-world application to provide valuable predictions and insight. Now, I want to say something. Welcome to this world. This is just a TK inter. There's more to this. The more you're getting stronger with front end, you can start using AWS, start using other tools. Because the last time I did a job for a company, an organization, I used AWS. Aside writing my backend, I used Flask to design my front end. Then to deploy, I use AWS, okay, which is EC2 or is it EC3? Well, no problem about that. Maybe there'll be a workshop for that on the long run. Okay, good. Now, if you check what's happening now, this is Positron. Pandas is not working. NumPy is not working. Matplotlib is not working. Scikit-learn is not working. What did I do? I installed them. Unlike when you download Anaconda and you store it on your machine. If you go to Jupyter Notebook, If I said import pandas as speedy, there will be no error. It will work straight. But in this case, I need to install pandas. I need to install NumPy. I need to install matplotlib, and I need to install scikit-learn. Now, if you want to install in Python, you do the pip install pandas. At this junction, if I'm working with Jupyter Notebook, I'll say pip install. But this time around, percentage, that's the percentage sign, pip, space install, space, whatever library you want to install. So I did this for here. Okay, so let me go down. Now, at this junction, we want to work with a back-end state. This is a back-end state now, where we train the model. So what are the possible libraries I use? The necessary libraries I imported was NumPy, was pandas, NumPy and pandas for data importation and data manipulation. Case one. Scikit-learn. The first scikit-learn you're seeing there for model selection, where I splitted my model into training and testing, is family of scikit-learn. Whenever you see scikit-learn, just know that at that junction, they have implemented machine learning. I can do a data analytics without no machine learning. I will never mention scikit-learn or any machine learning libraries, but only NumPy and pandas and other statistical tools, our libraries. But at this junction, whenever you see an sklearn, just know that machine learning has come to play. Okay. Now, I also call scikit-learn for linear regression. Then I imported what they call job_lib. The job_lib function is for me to save a model. Do you get it? I saved model. Now, I only did linear regression here because I want to save time. Do you get it? On a normal day, as a data scientist, if I'm given a job to work, I'm given a data set, I know my problem, I have a data set, I discover my features and my target. I will make sure I implemented more than 5 machine learning algorithms. So the algorithm that is best is what I'll pick. So by assumption now, I'm picking only linear regression that is the best model. So I moved. That's what I'm trying to do here now. So first thing first, I generated a dummy sales data. Are we good? I generated a dummy sales data. Okay. At this junction, what did I do? Because it's a random data generated, what did I do? I set a seed, set random.seed. Mind you, in a previous class workshop we had, which is yesterday, if I'm not mistaken, I created a random selection. I did set.seed. That's for R programming. But in this case, I'm doing random.seed. Set.seed is when you're working with R. Random.seed is when you're working with Python. Oh, sorry for that. Okay. Can you hear me now? Am I audible now? Hello?
Yes.
Oh, thank you for that.
Better now. Thank you.
Okay,
yes,
now.
Better now. Thank you.
Okay, at this junction, now, first thing first, I didn't say random.seed. I said np.random.seed. NumPy. The function of NumPy talks about number Python. Anything I want to deal with numbers, that's where NumPy comes to play. Are you good? Arrays, matrix, and the likes. Okay, so now, what did I do first? I created a dictionary. If you check, look at it, look at this symbol, it's for dictionary. Are you good? So I have advertising. I created a random set of numbers. Okay, then I have price, I have numbers of store, I have promotions, I have customer rating. Aside doing this is just a dictionary. For me to make it, okay, this is just this we have here are the 5 inputs, which is the what's it called? The independent features. Why my targets here is dependent features. Now, at this point, aside all this, I need to make them a data frame. Like I said earlier, data frame means they are in tabular format. They have rows and columns. Then I create a data frame. I create a data frame for the data that I created in dictionary. But mind you, the data I created does not have a target. So I need to input a target. That's why I said, remember what I did when I have a data frame, then I now want to create a new column. I now said, okay, let the new column be target. Okay, I need to take you back to one place. Pardon. Okay, 1 minute, please. It's very, very important. I intentionally did all this. Okay, good. So please, this section will end in the next 10 minutes. Kindly join back when it ends, please. Okay. Now, please.
Yes, I have a question, sir.
So what's your question?
I have a question.
What's your question,
Yes.
sir?
I must first of all appreciate you for your time and for making it possible for us to be able to add this data science knowledge, especially on the programming aspect. But
Okay.
however, my question is I want to see this. If we are programming, we should be able to use offline server where we can use browser, any of the browser, either Firefox, so that we can see the result direct from it. But most of the time, when we're programming like now that we're using the Positron software environment,
Okay.
the result I expect to see not the aspect I'm a software developer.
Hello, sir. I lost you there. I lost you there, please. Can you
Just
just
assume maybe you develop a website, you be on the browser, but the way
Okay, so you mean that when I run the code, there should be a browser where the result will come out from, right?
what you are teaching us and trying to look at
Hello, sir. I lost you there. Your network is not that strong. Hello, sir. Can you hear me? Your network is not strong. I lost you.
Maybe people should write down their question
Okay,
and
good.
ask later.
Yes.
Okay, sir, please put it on writing. Put it on writing so that once I'm done. Sir, your network is weak.
Any way we can use the code.
Yep.
Please, let's continue, sir.
Okay. So do you know what? Kindly put it on writing on the message there, on the chat. So once I'm done, I'll read your chat and I'll reply you positive. I think that's fair enough. Okay. Your network was kind of weak. Okay. A quick one. I was trying to bring you guys to somewhere. Now, look at something I did. I added this, a new column. The column there was age, name, age, city, and class. So I added this one, right? So that's what I just did here. So I need to add targets to this data. So that's why I said, okay, well, let target, okay, where is it? Let the df, the name of the data frame is df, add target to it, which is target. Then, good. So when I did that, I think I'm good. Mind you, after data importation, the next thing is called data preprocessing. You have to clean your data set by checking for outlier, by checking for missing value, by rescaling it, letting them be in a range of, when I say the word rescaling, we have two kind of family. Either you're standardizing or you're normalizing. So what do I mean by standardizing? And what do I mean by normalizing? Now, rescaling actually means that if sales is 10,000, 15,000, 20,000, and your input is 0.01, 0.02, 0.03, doesn't match. So you have to make everything to be within a set of range. So when you are working or when you are visualizing, the charts will not go out of proportion. They always want to be conformed. Now I didn't do those things. I didn't do data cleaning and the likes because I generated a random number, which is ideal, which is clean. So what I did is, the next thing, once your data is good, you split your data set into two. Splitting means you indicate your dependent variable an independent variable. This thing I just mentioned, family of statistics, they understand that very well. But mind you, we have the features and the targets. When you split into X and Y, your X is your independent features, while your Y is your dependent one, which is the target. So I have split them like this. Now, the next thing is, I now use the train test syntax. We have the X train, X test, Y train, Y test. Why am I splitting it into X train and X test? Like I said earlier, your training data set is for you to build a model, while your testing data set is for you to predict your model. Training to build model, the testing, the test data set to predict for your model. Okay, at this junction, I use this train test split here. You are seeing it's coming from the library. Look at it here. This one we have here. Look at it. The alias. Okay, not even the alias. I said from sklearn.models underscore selection, import train underscore test underscore split. Okay, so that junction, what's happening? So my test size is 20%, 0.2. So I said random state to become 42. This random state means that if I run it again, the data set that it will, this splitting is what happening randomly. It's not just splitting the first 20 input or the first 15 input is picking it. No, it's not doing that. It's picking it randomly. So I now said random state to be equal to 42. That thing I did there is telling me that if I run this code 10 times, the set of output that I brought out, the random number that I picked out initially, it should be able to give me back. If I didn't do random state, it will give me another selection of number. If I run it again, it will give me another random selection of numbers. So I want to maintain a particular set of number so that I won't go out of key. That's why I wrote the random state to be equal to 42. Okay, so at that junction, what will I do? Then I have to form my model. So forming a model, there are a lot of machine learning algorithms which you can train model on, but I choose to do only on linear regression. We call this linear regression an OLX, ordinary least square model. So what I do, I say model is equal to linear regression. This linear regression you are seeing here, look at it up there. Let me show you in the library part. Look at it. This is linear regression. Are we good? Okay. Okay. So when I did that, I now say fine. It's okay. They need to fit for you to train a model. For you to formulate a model, you need a training data set. Data model will be Y is a function of X. Y is the output, X is your input. That's why I said, okay, model.fit. I have X train and Y train. I didn't put X test and Y test. If I want to put family of tests, that's what I'm predicting. But for me to get a model, the train data set is what is needed. And train data set have been called here. I have 4 sets of data sets here. X train, X test, Y train, Y test. So I use the X train and the Y train to build my model. Okay. So when I did that, it actually worked well. So then this model that I created, what will I do? I have to save it. Saving your model at this junction, that's where the job lib library comes to play. So for me to save a model now, I will use dump. For me to load a model, I use load. So for me to save a model now, I say job lib dot dump. This model you're seeing here is the name of the model that I called. Then I now want to name the model. The model will occur in my working repository, which now is my download, as what? Sales underscore model.pk1. Okay, now let me run this. Let me go to my download first. My download, this is my download. Refresh. Now, this is my download. There is no sales underscore or whatever this. Let me see that thing again. There's no sales underscore model.pk1. It's not there. So if I run this thing now, let me run this. Run. It's counting. Now, for you to bring an output like this, it shows it has saved. Let me go to my download, whether it has bin saved there, because job link.dom. Yeah, can you hear you, sir?
Yes, that is the next 5 or 7 minutes. This link will go off again, so we have to done again. If you
no
are
problem,
not
sir.
done yet. All right.
Okay.
Okay.
So let me go to my download to check what's trending. So I'll go to download. Okay, let me refresh. Wow, have you seen it now? Look at the time. Today is 27.